The college applications in India is cursed. You have to fill documents after documents, only to realize you have completely lost track of what's covering what. Welcome to day 8 of T20 DSA challenge. Today we are solving the overlapping sheets problem. A nightmare for perfectionists, but a gold mine for people like you. Let me guess, what are you thinking? This looks easy, just some areas and subtract overlaps, right? Wrong. The moment you see n equal to 100 rectangles, your O of n square solution collapses. And that's where 90% of you all get stuck, drowning in edge cases. But here's the twist. What if I tell you this problem has a secret weapon hidden in plain sight? Just look at the constraints. X and Y coordinates go up to 100 and 100. That's not a limitation. It's a... Imagine dividing entire plane into 1 by 1 squares. For each tiny square, ask if any rectangle is covering you. If yes, count it. Sum all your squares, boom, total area. No overlap at all. This is grid sweep technique. It's like using a microscope, zooming in until the complexity vanishes. But here's the kicker. With coordinates less than or equal to 100, there are only 10,000 unit squares to check. Even for n equal to 100, this is lightning fast. Pause the video right here. But wait, do you trust this approach? What if two rectangles partially overlap in a square? What if edges do not touch? Here's the beauty. A square is either fully covered or not. We don't care how many rectangles cover it, just if any do. Let's test it. Take the first example. 3 rectangles. Using grid sweep, we can check each unit square between x equal to 0 to 5 and y equal to 0 to 5. Count the cover squares. Result 20. Exactly matches the sample. Now the second example. 2 identical rectangles. Grid method counts 100 by 100 squares once. Perfect. This is why DSA is an art. You could have wasted hours of complex geometry formulas. Instead, constraints are clues. And they're screaming, use grids, Babu. And today, you have learned to listen. It's your turn. Implement this with nested loops. Outer loops for x and y and inner loops for rectangles. For each square x, y, check all rectangles. Brute force? Yes. Efficient? For n equal to 100 and 10,000 squares? Absolutely. Drop your code in the comments. Our problem setting team will review your approaches tonight. And remember, every day you stick with this challenge, you're one step closer to AUDEVDAY passes, swag, and that sweet DSA roadmap.